Welcome to qnawire.
Hello, in the question we have given that a student pulls on a cart. So let us and applies a 20 Newton force at an angle of 25 degree above the horizontal. So let us draw one cart. So this is our cart. Now this looks like a block, but consider it as a cart and we will solve this problem. So there is a force applied in this direction like this, and this force is applied by the student. And so this force is at an angle of 25 degree above the horizontal, not 30. Sorry, this is 25. This angle is 25 degrees. So let us write the forces also. So this will be F cosine of 25. This force out here will be F sine of 25. The component of forces. And so this is the force. Now what they are saying that to move create a distance of 10 meter across the rough floor that that creates a frictional force of 2 newtons. So there is a frictional force also they are saying. So first of all we have to draw the free body diagram. So part A, we have to draw the free body diagram. So there will be a downward force mg, there will be upward force n, normal reaction force, then there will be a frictional force out here like this. So done. Now what we have to do, second part. So how much work does the student do? Now student applies a force. So this will be the work done by the applied force. So we are finding the work done by applied force. So if I want to find out the work done by the applied force, then so work done is F dot S. Now who is applying the force? Student. So applied force. Student is applying the force. Now will the sign component get involved in the work done? No, because it is horizontal. It is perpendicular. So it will be 20 because the force is 20 cosine of 25 into 10 because the displacement in 10 meter. So it is 18.126 into 10. And if we calculate this, we will get the answer as 181.26. So this is the work done by the student. And sorry, I forgot to put the unit. So the unit will be joule. So this is the work done. Now moving further. So part C. So what I have written over here? 2, 3. So see the chronology. Now third is what is the total work done? Now total work done, now it will include the frictional force also. So total work is work done by the student and work done by the friction. So total work done. So the total work done will be W is equal to F net times displacement. So what is the net force acting on it? So it is 20 cosine of 25 minus 2, that is the frictional force, times displacement, which is 10. So if we calculate this, so it is 18.126 minus 2 times 10. So if we calculate this, we will get this answer as 161.2 joules. So this is the total work done. Now having done this, we will move on to the part 4. Now in the part 4, what they are saying, if the cart start from rest, how fast will it go after 10 meters? So in this case, we will be we are unable to solve this problem because the cart mass is not given. If the cart mass was given, we could have simply solved it. But I will give you the recipe of how to do it. So now we can use the work energy theorem over here. So work energy theorem, what it says, work done is equal to the change in kinetic energy. So work done is how much? 161.2, and change in kinetic energy is half mv square, because initially, so vf square minus half mvi square, let us write, but this is 0. Why? Because initially it is at rest, so vi is 0. So from here I can calculate this final velocity, but the thing is mass is not given, and if mass is not given I cannot do that. So I can use this formula also, v square is equal to u square plus 2as. But here acceleration is not given. I can use Newton's second law of motion, F is equal to mass times acceleration, but then mass is not given. So if it is given in the question, so you can just plug the value of mass over here and calculate the velocity. I hope you find the solution useful. Thank you.